Number 15. Okay, this is a chapter is wave. Now we give the definition. What is wave? Okay, so we can say the wave is a disturbance that propagates in a space, transports energy and momentum from one point to another point without the transport of matter. Okay, this is called wave. Just simple definition: wave is a disturbance that propagates in a space, transports energy and the momentum from one point to another point without the transport of matter. Okay, this is called a wave. Now that is simple. According to the idea of wave, if we want to communicate our friend, okay, we want to communicate our friend. Okay, I live in Bhavnagar and my friend is in live in Ahmedabad. So I want to communicate with my friend. So there are the two types of two way. First, I write a letter, and second one is I write use the phone. Okay, write a letter. This is a concept about this is the particle, and this is concept about wave. Hmm? If we speak, there is some type of particle that is move in the medium, and it is just like the as a form of wave. Okay, suppose કે particle હોય, this is periodically move in the medium, so this is called a wave. Okay, now the classification of wave, very simple. What is the classification of wave? Classification of wave, we discuss about basic function of wave. First one is I discuss, this is a necessity of medium, necessity of medium. Okay, so any under I can say this is elastic or mechanical wave. This is called mechanical wave and electromagnetic wave. Okay, mechanical wave. What is the mechanical wave? That is simple. A wave propagate in a medium using a wave is propagated in a medium using the some type of material, some type of medium. This is called a this required a medium. Okay, for the propagate it required a medium, so this is called a mechanical wave. Okay, electromagnetic wave, otherwise it is called a non-mechanical. Okay, so non-mechanical કોને કહેવાય? So that is not required a medium to propagate a wave. This is called a non-mechanical wave. Propagation of energy. Okay, this is a progressive. First one is progressive, second one is stationary. Okay, now we discuss about the progressive and stationary wave in this chapter. Now third one is dimensions. Okay, so this is the one dimensions, we can say it is two dimensionally. Okay, and third one is three dimensions. Wave propagating in the medium as one dimensionally, two dimensionally, three dimensionally. I give example one dimensionally, just one. If we oscillate the strings, okay, we oscillate the strings at this time, this is called a one dimensionally. Two dimensionally means જ્યારે કોઈ આપણે પાણીમાં પથ્થર ફેંકીએ છીએ, બરાબર ને, ત્યારે that propagate a wave, this is two dimensional. Three dimensionally means we can say just simple example. થ્રી ડિમેન્શનલ માટે આપણે સપોઝ કે એક આપણે એક્ઝામ્પલ આપણી પાસે છે, પણ જરાક થોડું વિચારવું પડશે એની માટે. યસ, ધ વિઝિબલ લાઇટ, બરાબર, વિઝિબલ લાઇટ હોય, this is the propagate in the medium, it is three dimensionally. Okay, now the fourth one is vibration of particle. Vibration of particle. Okay, this is a transverse, longitudinal. Okay, there are the two types of vibration of particle. This is a transverse and longitudinal. Transverse means the propagation of the wave, the oscillation of the wave, it is a perpendicular, it is a normal to the propagation of wave. Okay, એટલે સપોઝ કે આપણે સાદી અને સિમ્પલ એક આની માટે થોડી ડિસ્કશન કરીએ. સપોઝ કે this is the propagation of wave. Okay, now this is particle if oscillate in this. This is perpendicular to the propagation of wave. This is called a transverse wave. Okay. Now, once again, I write the propagation of wave. Achha, okay, sorry. This is called a longitudinal wave. Okay, this is called a longitudinal wave. It means this is the oscillation in the direction of propagation of wave, and this is the perpendicular the propagation of wave. That are the difference between that. This is called a transverse wave and this is called a longitudinal wave. Okay. ચલો હવે આપણે આગળ જોઈએ. Now we discuss about wave equation. Okay, what is the wave equation? That is very simple. Suppose okay, this is called the simple, I can say it is wave. Okay, this is called a crest, a new words for us. This is called trough. Okay, so crest means positive part, trough means negative part. In some time it is positive, in some time it is negative. This is positive, this is negative, and it propagate periodically. It propagate periodically in medium. Propagate in medium. Okay, simple. Now the wave equation, y, the displacement, y is equal to displacement of wave. So this is y is equal to a sine omega t minus kx. A is equal to, this is called a amplitude, and the maximum displacement, it is called maximum displacement. The maximum displacement at the, suppose ke here the, it is start from this point and it is goes further and it reach the point, after that it changes its direction. પેલા direction આમ હતી બરાબર, પછી direction આમ થાય છે. Okay, so this is called the maximum displacement, it is plus a. After that we can say this is the maximum displacement in the negative, so this is called a minus a. Okay, and it oscillate between plus or minus a. The wave oscillate between the plus or minus a, and it is called the maximum displacement at the one direction. Okay, yes. Now omega is equal to angular frequency. Omega is equal to what? Angular frequency, and this is called a 2 pi f. Okay, omega is equal to called 2 pi f. This is called a angular frequency. Otherwise I can say this is 2 pi upon t. F is equal to frequency, t is equal to time period. Okay, one oscillation completed in 1 second. Okay, this is called a frequency. Done. ચલો, એટલે એમ કહે છે કે oscillation in 1 second. Okay, this is called frequency, and after that we can say a time in which it completes the one oscillation. This is the called time period. Okay, now k is equal to, yes, wave propagation, otherwise wave vector, or the wave propagation. Okay, this is, I can write it is 2 pi upon lambda. What? This is 2 pi. The unit of omega, it is radian per second. Unit of k is equal to radian per meter. Okay, now all are, we know y is equal to displacement, a is equal to amplitude, sine, it is a sine, otherwise we can write it as cos. Okay, now when the minus kx given, minus, what is the wave propagation shows? It shows a direction of, it shows a direction of wave. Okay, એટલે કે એ x direction માં જાય છે, y direction માં જાય છે. Okay, so this, from this we can decide it is in the x direction, but x direction ma plus x ke minus x, when minus kx is given, so that it propagates in plus x direction. ધ્યાન રાખજો બરાબર. આ તમારે આનું ડિસ્કશન આપણે નહીં કરીએ, કારણ કે સીધું યાદ રાખવાનું છે. plus kx is given so that it propagates in minus x direction. બરાબર ને? Plus x is given so that it propagates in minus x direction, minus kx given so that it propagates in plus x direction. Okay, now we discuss about the wave velocity. What is the wave velocity? Simple. If we take omega upon k, omega is equal to what? 2 pi f. K is equal to, આગળ જોયું, 2 pi upon lambda. 2 pi cancel, so f into lambda is equal to v, and v is equal to called a wave velocity. Okay, this is called a wave velocity. Acha, we discuss wave velocity and we discuss wave. We will discuss the velocity of particle. What is the difference between that? So very simple. If I assume the string and the particle on this string, I assume. Okay. After that, the wave is coming. Acha, otherwise, આપણે આને શું કરીએ છીએ? We oscillate on both sides. So this is the particle is just like oscillations. સપોઝ કંઈથી વેવો નીકળે એટલે આ રીતે ઓસિલેટ થાય છે પાર્ટિકલ આ રીતે ઓસિલેટ થાય એટલે શું થાય છે? that produce a wave. Okay. Okay, this is completed one oscillation, and this completed one oscillation. I can say this is the lambda. Lambda is equal to called a wavelength. What? It is called a wavelength. Okay, this is called a lambda. Okay, so if when wave propagates in the medium, particle oscillate around its middle point, middle point. It means I can say कि कोई पण particle છે that is not propagate in the medium but it oscillate around its middle point. એટલે કે એ middle point ની આજુબાજુમાં શું કરે છે મિત્રો? oscillate કરે છે. This is the concept of the particle oscillate. Okay, but we can say the from this, according to this, the oscillation of a particle, we can say the wave is propagated in the medium. Okay, so now next time we discuss about a velocity of particle. Okay, what is the velocity of particle? That is discussed in next lecture. Okay, ચલો આટલે સુધી રાખીએ છીએ. Thank you very much. Take care. Goodbye.